Good morning students. Today we are going to see about the topic dynamic programming. So dynamic programming is one of the famous algorithm technique to solve various data structure problems. The objective of our video is to small introduction about dynamic programming and how to solve Fibonacci problem using dynamic programming, and what is the difference between recursion and dynamic programming, and finally we have to see about the shortest path problem and its famous algorithm. So dynamic programming is nothing but is a general algorithm technique to solve various data structure problems using define the recursion techniques with overlapping subproblems, which is invented by American mathematician Richard Bellman in the 1950s to solve optimization problem. Later it is adopted by computer science. The main idea of dynamic programming is to set up the recursion of solution to the large instance to solve the solution of smaller instance. That is, to solve smaller instance once and store the solution in a table and extract that solution to the initial instance from that table. There are two methods to storing the results in memory. One is memorization, another one is tabulation. Memorization is top-down approach and tabulation is bottom-up approach. So, okay, where we have to use dynamic programming? So, the dynamic programming is mainly used for a particular problem. If your problem have major two properties, overlapping subproblem and optimal substructures. These properties attained by a problem, then we can solve that problem using dynamic programming. So, let us see one example. Fibonacci series. We are already familiar with Fibonacci series. We just recall the definition of Fibonacci numbers. So, we know that Fibonacci number is nothing but addition of previous two numbers. So, that is f of n is equal to f of n minus 1 plus f of n minus 2. So, initially we take f of 0 as 0 and f of 1 as 1, like f of 2 is equal to f of 0 plus f of 1. So, computing this Fibonacci number in two methods, one is top-down approach, memorization technique, another one is bottom-up approach, tabulation techniques. So, this is one example for top-down approach. First we have to calculate f of n. For calculate f of n, you need to calculate f of n minus 1, f of n minus 2. So, for f of n minus 1, you have to calculate f of n minus 2 and f of n minus 3. If you similarly parallelly you have to calculate f of n minus 2, we need to calculate f of n minus 3 and f of n minus 4. So, here repeatedly you have to calculate f of n minus 2, f of n minus 3. So, for this we have to store that value in table in memory and then reuse the values instead of calculating again and again. So, this is bottom up iteration methods. First we start from 0. For top-down approach, we have to start from n. For bottom-up approach, we start from 0 to n. So, first we have to store f of 0, f of 1 and f of 2. For f of 2 is equal to f of g1 plus f of 1. Likewise, f of n is equal to f of n minus 1 plus f of n minus 2. See the table. This table, first we have to store f of 0, 0, f of 1, 1, f of 2, 1. Likewise, finally we have to store f of n minus 2, f of n minus 1. Finally, f of n, we get the f of n value. This is bottom up iteration, that is tabulation approach. So, this is sample Python program. So, here first I declared list memory, that is memory I can represent as MEN, mem is a list type, and define a functions fib of mem within the bracket n. If n is not equal to null and f is n is less than 2, return the n value, else we have to recursive manner f of mem equal to n minus 2 plus f fib of nim n minus 1. So, finally, the result will be returned. So, this is enough to cause the tree structure to collapse the graph as shown in the figure. Fib of m of 4, fib of m of 3, fib of m2, fib of 1, fib of 0. So when fib of 2, we need to calculate fib of 1 and fib of 0. For fib of 1, it is already computed, and if fib of 2 for fib of 3, it is also already computed. So already computed value, then I didn't compute again and again. I just store, already I stored it, store the value in the list. So I use the list value. So this is iteration approach, that is stabilization method. So first I start from introduce mem list in a list variable, and mem of 0 is equal to 0, mem of 1 equal to 1. In iterative manner, f of 1, mem of 1, mem of 2, mem of 3, likewise mem of n up to I calculated, and return the final value, because the final value is stored in the last variable, mem of n. Okay. So we have a doubt. So we use, this is recursion approach, this is iteration approach. So what is the difference? What is recursion versus dynamic programming? Because we solve dynamic programming using the recursion also. So what is the difference between recursion and dynamic programming? Let's see. So recursion is nothing but it's a function we can call and executed by itself. But dynamic programming is the process to solve the problem by breaking down them into sub problems to resolve the complex one. The main difference between the recursion and dynamic programming is nothing but recursion is an automatic function. We can use any kind of function in using recursion manner, but dynamic programming is the optimization techniques to solve complex problems. In dynamic programming, we store the result, intermediate result in a table. We store the intermediate results in table, right? In both the program, first program and second program. In both the program, we intermediately store the result. But pure recursion program doesn't store any result, intermediate result. And dynamic program can function without using recursion techniques, but many programmers, to solve the problem, to solve the optimization problems, programmers tend to use the recursion to oscillate and optimize the process. So finally we see the shortest problem, some of the shortest problems and famous algorithm. We will discuss about it. In graph theory, the shortest path problem is a problem to finding a path between two vertices. Generally we call it as finding a path between two vertices in a graph, such that the sum of the weighters is minimized. So it's also another constraint. So first we have to find the path between two vertices, and also the sum of the weights between the path is also minimized. So this is the, generally we can call it a shortest path problem. So the shortest path problem can be defined for graph, whether it is a directed graph or undirected graph or mixed type. So based on that, we can define the shortest path problem. So generally for directed graph, the definition of path requires the constitutive vertices by connected by its appropriate directed edge. Let's see some of types of the shortest path problem: single pair, single source shortest path, single destination shortest path, all pairs shortest path. These are the different types of path problems. So let's see some famous algorithm. So this is our famous algorithm for solving single source shortest problem. Dijkstra and Bellman-Ford algorithm is very famous algorithm, but the Dijkstra algorithm is solve the problem only with non-negative edge weight, but Bellman-Ford algorithm, it works on even the edge weights may be a negative. And A star search algorithm, it is used to solve the single pair shortest path algorithm to speed up the search. And finally, all pairs shortest path. To solve that type of problem, you can use Floyd-Warshall algorithm and Johnson algorithm. The Johnson algorithm is very faster than Floyd-Warshall algorithm on sparse graphs only. Okay. So other than many shortest path algorithm is available. So these are some famous algorithm. Okay. So we see the application of shortest path. Why we need to calculate shortest path? Why we need to choose shortest path? Because we already very much famous used Google Map and road networks, source in network analysis. So these are some applications of shortest path algorithms. So in next class, we will see about some shortest path algorithms. Thank you.